So let's do the basics tutorial now. This is actually quite a hard one because it's got a lot of code in it. So let's click on to, there's basics, basic demonstration. See, all the code is in one button. So let's quickly have a look at the code. Reminder, you can update this code. So this is a helper function right there. It's an async helper function which brings in a div, a tensor, number of columns you want, and a title for showing the code. Let me just show you what happens right there. So there's the title. It replaced the div on the page. I'm giving it 3 columns, and the tensor is inside. It just makes it easier to view. Okay, so let's go back to the code. I call that thing a ton, and the name of it is my tensor table right there. So remember, there's a lot of code here to get you used to the idea that you got to separate this information and go with the flow. So my div 321 is the main div. We're just going to set up a bunch of tensors. The matrix shape, I actually don't use this very much, but I'm going to use it this time. Here we have something called my weights. It's a TF for TensorFlow, not DL for deep learning. It's a tensor 2D. You don't actually have to do the 2D, but it makes it easier to read. And here is my flattened format tensor with its matrix shape. The next one, same flattened format, but they're different numbers. This is point, these are decimal, these are integers, matrix shape. Now let's show this thing. So my tensor table, we're awaiting, we're inside an async function. We're in waiting, we're passing a div, the weights, 3 columns, and there's the title. And then, what's this one doing? Oh, this is doing weights and inputs. And weights and inputs is a typical neural network kind of terminology of how much something's weighted and what the values are. So first of all, let's flatten this again. So we're going to do my inputs, this one, and we're going to flatten it so it's not in an array. It's in a, well, it's still an array, but it's a flat array. So I'll click on that in a minute. And once again, await the tensor table. There we go. Flatten arrays is the title. Let's try some scalars. TF scalar 2.3. Await. It's just showing you how to present this in an async fashion. A lot of the examples I could have written capital letters sync, S-Y-N-C, and not used await. But we're trying to teach you to be able to use it in the code you'd probably be using. So it's better to learn data and then be able to use data sync later on. So it's just outputting some information. Here it's, oh, here we have mapmul. So it's matrices, multiplication of weights and inputs, and it is printing it to the screen. Probably a good time to run this program. Remember, there's a lot of code in the one button. So here we go. There are weights. There's the input. Notice it's 1, 2, 3, 4, 5, 6, 7, 8, 9. But because I've described 3 columns, it's doing it nicely 3 by 3. Here's the flattened input. So that same thing flattened in a flattened array. It could come out this way or that way. I just gave it 1 column. I could have given it 9 column. So back to the scalar one. Remember we looked at the code for the scalar. It's just outputting the 2.3. Notice rounding. It's kind of 2.3, but it's being rounded. That's how TensorFlowJS works with these numbers. This is the product of weights and inputs. Yeah, we did mapmul, tf.mapmul, and so it's multiplying these 2 things together. So let's get back to the code. Way down here. Where were we? We multiplied, so there we are. So what now? Same thing, but a bit more complex. Now we're using 2D matrix. We're calling the matrix 1 and matrix 2. 2D. Notice I'm dealing with the shapes. This matrix multiply is transposed regular, whereas the next one is regular and transposed. So the first one, the first matrix is transposed. On the second run, the next matrix is transposed. And How do I view over? Let's see the code for this one. Okay, so way up at the top, here we go. So there's matrix 1, there's matrix 2. Here's mapmul, multiplying the two matrices. Here's mapmul, but the first matrix is transposed, the second one's regular before doing the matrix multiplication. Here it's just reversing them. Matrix 2 times matrix 1. Here matrix 2, matrix 1, but the second one is transposed this time, the matrix 1. And notice we're getting different numbers. This one looks kind of the same as that, but the numbers have just been flipped. These ones are kind of similar, but the numbers, there's 21 and 16, here's 21 and 16 going that way. So that's why that was more complex. Let's go down, have a look at the code again. We're on the third batch. Once again, get used to lots of information on a page. Kind of cruel of me to do this on the almost second one. Okay, here's where we were. Now let's try some one-dimensional tensors. So TF, tensor 1D, is W for weights, I for input, B for bias. And there we go, it's a 1D, this is a 1D, that's a scalar. We're just first of all writing them. And then what are we doing? We're using the tidy command. The tidy command is really handy, but it's not perfect. Dispose is another way of working with things. It depends what you want to control. Probably a good idea not to have an await inside the tidy command, but what it's going to do is it's going to get rid of my dot, my add, my sig, but it still will return the information my sig. So let's see what's happening. Outer product, it's like dot products of weight and input, and then it's adding the dot product with the bias, and then it's sigmoid function to that answer, okay? And then it's returning my sig. Here, this is comments bracketing this out. It was printing to the console, but I prefer waiting and printing it onto the web page, okay? This is the long form. This way is the long form of doing the sigmoid add dot product of the weights, inputs, plus bias. Now, the next one is going to do the exact same thing, except we're doing a sin h, not a sigmoid this time. And we're not going to do this way of adding it. We're going to string these operations together. So we're doing the last one first, sin h of the add of the outer products, waste I, and here we're adding the b. I actually like this way. I don't like that way to get things working, but I really like that way to read it. Because look at this. I'm doing the outer product of weights and inputs. I'm adding the bias to it, and then I'm taking the sin h, different function than sigmoid, of it, and printing the answer out using the tensor table. We'll have a look at it in a minute, but let's do another way. The other way is to string the operations one after another. And this way works fine too. Notice way less code. Now we're doing TF outer product. Then we're dot adding B. Then we're dot prelude. Instead of sin h or sigmoid, we're doing prelude of the scalar with a 0.1 function to that scalar. And it's outputting that. And this last one, we're not even going to use tidy. We're going to go back to the long form. So outer product, weights and inputs. Then we're adding the bias. Then we're doing relu this time. And we're awaiting, but here we're disposing. Okay, once we've printed it to the screen, we don't even need the answer. So my dot dispose, my add dot dispose, my answer for dot dispose. Supposedly tidy sometimes doesn't clean things up, and it doesn't clean up variables. So this knowing about dispose is kind of useful. So that was a really long function with quite a bit of output, but a good idea to get used to. Read the code over and over. Have a look at what it's outputting, because in machine learning there is going to be a lot of code. Anyway, have a good day.